Good morning, everyone. Welcome to the next lecture. In the last lecture, we discussed the future value and the present value of a given amount. Today, we are going to introduce a financial concept which is known as annuities and its various types, and also we are going to find out the present value and the future value of different types of annuities. See, what is an annuity? We hear this particular term especially in the insurance and banking sectors. See what actually the annuities means. See, an annuity is a fixed amount which is payable periodically at equal intervals, or we can simply say that it is the series of payment at a regular interval which may be weekly or maybe monthly or maybe yearly. So this means that if we pay or receive a particular amount at a regular time period or regular interval, then this type of amount is generally known as it is annuities. The interval may be, what I have already told you, the interval may be a particular year, or this payment may be half year, or the payment may be done on the monthly basis, and so on. And the important thing here that the payment must be the equal amount and the interval between the payment must be regular. So the regular payment may be monthly or maybe yearly or maybe every 6 months, like that. So for example, if you rent a particular flat and promise to make a series of payment over an agreed periods. For example, if you rent the flat and promise to make a series of payment over the agreed period, you have actually created an annuity. So based upon that, see, we have a different types of annuities. The annuities are generally divided into two basic types, that are ordinary annuities and annuities due. Ordinary annuity and annuities due. Let us discuss one by one. See, the first one is an ordinary annuity. See, an ordinary annuity is also known as it is a regular annuity. Where the ordinary annuity we can define, see, which is the annuity where the payment is made at the end of each payment interval. That means, in the case of regular annuity or ordinary annuity, the payment or receipt occur at the end of each period. For example, see, the bonds are generally pay interest at the end of every 6 months. We can count here the various features or characteristics of an ordinary annuity. See, in the case of an ordinary annuity, we can say that the amount of payment should be the same. The amount of payment should be the same or it is fixed. And the second most important characteristic is, see, the interval time between the payments must be the same or it may be a regular payment. So, and the payment should be made at the end of each period. This is also another important feature of ordinary annuity. So, I hope it is clear to you. So, an ordinary annuity where generally the payments are made at the end of each period. Now, what actually the annuity due? See, here in this case, annuity due is the payment or receipt which occur at the beginning of the each period. See, as against the ordinary annuity, here the annuity dues are where the payments or the receipts are made at the beginning of each period. See, one of the classic example of an annuity due is the rent. So when you sign a lease for the apartment, you commit to pay the rent on the first of each month. And this qualify the annuity due because the payment occur at the regular interval or monthly basis. At the beginning of the each period, you are going to pay this particular rent. So annuity dues are the payments where occur at the beginning of the each period. Now we want to find out the future value as well as the current value of an ordinary annuity, where we already said that an ordinary annuity where the payments are made in a regular basis and which is at the end of the each period. So here we are going to discuss how to estimate the future value of an ordinary annuity. So we know the future value, which we are already defined in the earlier lecture, which shows that how much series of regular payment will be worth at some point in future given a specific rate of interest, which means that the future value of annuity in total amount one would have at the end of the annuity period if the amount is invested at a certain the rate of interest, and we can say that which is held to the end of, or which is payment is made at the end of annuity period. So here the example, if you plan to invest a particular amount in a regular interval, say for example each month or year, it will tell you how much will have accumulated as of future date. So if you are making a regular payment on a loan, then the future value is actually very useful in determining the total cost of the plan. See, let's see, rather than calculating each payment individually, then adding them up all the, it is very difficult task, especially for the longer gestation period, as we are already explained in the last lecture as well. So for simplicity, we are going to use a particular formula which will tells you how much money you would have in the end of that particular period. See the formula given here, the future value of an ordinary annuity, that is equal to C into 1 plus I raised to the power n minus 1 whole divided by C, here it is I. See where we can say that C is equal to, which is cash flow for the period, per period, how much you are paying in a particular period. And I here it is the rate of interest, and n is the number of payment or year. So by using this particular formula, see, it is the future value which is equal to C into 1 plus I raised to the power n minus 1 divided by I. So in this particular formula, see, 1 plus I raised to the power n minus 1 divided by divided by I, which is generally called the future value of interest factor of an annuity. It is the future value interest factor of an particular annuity. Now based upon that, we can solve some examples. See here, suppose I invest rupees 1000 at the end of every year for next 5 years. If the rate of interest is 8%, then how much will my investment be worth after 5 years? So generally people wants to know this type of problems. That is, if I am investing today, then what will be the actual value in near future, that is after 5 years or maybe after 10 years at the given rate of interest. See here, we are going to invest 1000 rupee for the next 5 years at the rate of interest of 8%, and we want to know what actually my investment is worth after 5 years. So from the given equation, see, we can calculate the future value, that is future value of this type of ordinary annuity. See, here it is an ordinary annuity because it is the payment is made at the end of every 5 years. So this is a hint which is given in this particular problem, whether this particular annuity is an ordinary annuity or annuity due. So here the payment is made at the end of every year, so that we can say that this is a ordinary annuity. So here we can find the future value of an ordinary annuity by taking this particular formula. So what are the information given here? See, cash flow is given, that is how much you are regularly paying, 1000 rupees. Rate of interest is given, that is 8%, so it is 8 divided by 100, which is equal to 0.08. And n is equal to for next 5 years, so n is equal to 5. Now we can substitute all these values in the given formula, which is equal to 1000, C is equal to 1000 into 1 plus I, which is equal to 0.08 raised to the power 5 minus 1 divided by I, which is equal to 0.08. If you go for simplify it, then you just add 1 plus 0.08, then it is 1.0.8 raised to the power 5 minus 1 divided by 0.08. Then the value of 1.08 raised to the power 5, which is equal to 1.46932 minus 1 divided by 0.08. Then if you subtract the 1 from this particular value, then it will become, see, 1000 into 0.46932 divided by 0.08. If you go for dividing these two terms, then it will become, see, 1000 into 5.8665. If you go for dividing 0.46932 with 0.08, then it is equivalent to the 5.8665, and multiply these two terms, then it is equal to 5866.5. We're showing that after 5 years, your 1000 rupee will become 5866.5 at the given rate of interest of 8%. So this is an example of an ordinary annuity, how to find the future value of an ordinary annuity. Now consider the another example. See, what amount will accumulate if we deposit 5000 rupees at the end of each year for next 5 years? Assume an interest rate of 6% which is compounded annually. So again we want to find out the future value here, but payment is made at the end of each year, so that we can say that it is an example of an ordinary annuity. We can find the future value by using this particular formula, that is C into 1 plus I raised to the power n minus 1 divided by I. See, what are the information given here? C is equal to 5000. I is equal to rate of interest, which is 6%, so 6 divided by 100, which is equal to 0.06. Then n is 5, that is for 5 years. So we can substitute all these values here. So it will become 5000 into 1 plus 0.06 raised to the power 5 minus 1 divided by 0.06. Then if you simplify it, then it will become 1 plus 0.06 raised to the power 5, which is equal to 1.06 raised to the power n, that is 5, minus 1 divided by 0.06. Then the value of 1.06 raised to the power 5, by using the calculator, we can find it, it is 1.3382 minus 1 divided by 0.06. So if you subtract the 1 from this particular value, then it is equal to 0.3382. Then dividing 0.3382 by 0.06, then it will become 5.6366. Then if you go for multiplying these two terms, then it will become 28,183. So here the future value, that is the future value of the 5000 rupees at the end of 5 years at a given the rate of interest of 6% is 28,183. So this is the future value of the given ordinary annuity. Now consider another example. See here, a person planned to contribute 2000 rupees at the end of every year to a retirement account which is paying 8% is the rate of interest. And we want to find out, see, if the person retire in next 30 years, what will be the future value of this particular amount? So here the retirement planning is going on. See, he is going to contribute regularly at the end of every year, so that this particular problem will become, this particular annuity will become an ordinary annuity, because we are going to pay at the end of every year and at the rate of interest of 8% for next 30 years. So what are the information given here? See, we want to find out the future value by using this particular formula. See here the information are C is equal to 2000, I is equal to 8%, so it is equal to 0.08, N is equal to for 30 years. Now we can use this particular formula, substituting all these values here, then it will become 2000 into 1 plus I, this is 0.08 raised to the power for 30 years. So here it is 30 minus 1 divided by 0.08. If you go for simplifying it, then it is 1 plus 0.08. It will become 1.08 raised to the power 30. Then if you go for calculating the value of 1.08 raised to the power 30, which is equivalent to the 10.0626 minus 1 divided by 0.08. Then subtracting 1 from 10.0626, then it will become 9.0626 divided by 0.08. And if you go for dividing these two terms, then it will become 100 13.2825. So if you multiply these two terms, then the future value is equal to 22,06,565. It is 22,06,565. So after the 30 years, his plan, that is, he is contributing 2,000 rupees at the end of every year for next 30 years at the rate of interest of 8%. His total amount will become 22,06,565. Now we want to find out the present value of an ordinary annuity. Till now we were discussing about the future value. Now we are going to find out the present value of an ordinary annuity. See, as in contrast to the future value calculation, we can find out the present value calculation, which actually tells us how much money would be required now to produce a series of payment in future, again assuming a set of rate of interest. So simply the present value of annuities is the amount of money today which is equivalent to a series of equal payments in the future. So here we can find out the present value of an ordinary annuity by using an equation by changing little bit differences are there as compared to the previous formula. See here the present value is equal to C into 1 minus 1 plus I raised to the power minus n divided by I. So here PV is equal to the present value of the ordinary annuity, I is the rate of interest, then n is the number of payment. So by using this particular formula, we can find out the present value of an ordinary annuity. So let's do some practical problems so that it will be more clear, especially based upon this present value of an ordinary annuity. See, consider one example. We want to find out the present value of an annuity where the payment of 10,000 rupee are to be paid at the end of every year for 7 years at an interest rate of 12.5%. So here we want to find out the present value. So present value of 10,000 rupees, which is you are going to pay at the end of every year. So it is an example of an ordinary annuity because the hint is given, that is every end of every year for next 7 years at the rate of interest of 12.5%. We have the given information, that is C is equal to cash flow is equal to 10,000, rate of interest is equal to 12.5%. If you divide with the 100, then it will become 0.125 and n is equal to for 7 years. We know the formula for calculating the present value is equal to C into 1 minus 1 plus I raised to the power minus n divided by I. So by substituting all these values in the given formula, then it is equal to 10,000 into 1 minus 1 plus I, which is equal to 0.125 raised to the power minus 7. See, it is minus n, so it is minus 7 divided by 0.125. So if you go for simplifying it, 1 plus 0.125, so that is 1.125 raised to the power minus 7 divided by 0.125. So if you go for calculating the value of 1.125 raised to the power minus 7, so you can also use the calculator here to calculate this particular value, or you can also calculate this particular value because it is the raised to the power is minus 7, exponent is minus. So some computers or some lab calculator is not giving the appropriate value. So at that particular point of time, you can find it for this particular, take the reciprocal of this particular value, that is 1 by 1.125 raised to the power plus 7, not minus 7 at that particular point, because we are going to take the reciprocal. Otherwise, if calculator is providing directly this particular value, then you use the calculator and find the value of 1.125 raised to the power minus 7, which will give you, that is 0.43846. So subtracting 1 minus 0.43846, then it will become 0.56154 divided by 125. Dividing these two terms, then it will become 4.49232. Multiplying with 10,000, it will give you 44,923.2. So the present value of the given, the payment which you are going to make, that is 10,000 for the next 7 years at the rate of interest of 12.5% is 44,923.2. Now let us consider how to find the present and future value of annuities due. See, in the case of annuities due, we are already said that the payment or the receipts which are occur at the beginning of the each period as against the ordinary annuity, where the annuities are made, the payments were made at the end of every year. But here the payments will be made at the beginning of every year. Then we will see how to find the future value of an annuity due. We know the future value of annuity due, that is showing that the end value of the series of cash payment which is made at the beginning of the payment period. And this means that if you invest an annuity due, your principal will grow at the compounded rate. And to account for payment occurring at the beginning of each period, then it requires a slight modification to the formula used to calculate the future value of ordinary annuities, because it gives you a higher value compared to the ordinary annuity. Because see, the payments were made at the beginning of the period as against the end of the period, as we are already explained the case of ordinary annuities. So here the payments made at the beginning of the period, so that they have more time to earn the rate of interest. So accordingly, we are rearranged with a slight modification the earlier formula. See here, the future value of an annuity due is C into 1 plus I raised to the power n minus 1 divided by I into 1 plus I. And here the C is equal to cash flow per period, I is the rate of interest, and n is the number of payments were made. So by using this particular formula, we can find the future value of an annuity due. Let us consider some example. See, you invested on January 1st of 1,000 rupees every year for next 5 years at the 5% rate of interest, and we want to find out the future value of this particular given investment of 1,000 rupees, which is made on January 1st. On January 1st, which means that it is given hint for the annuity due, because payment is made at the beginning of the period, that is on the January 1st. So in this particular case, see, we can given the informations are C is equal to 1,000 rupees, the rate of interest I is equal to 5%, that is 5 divided by 100, which is equal to 0.05, n is equal to for 5 years. Then we can find the formula for calculating the future value of annuity due, which is equal to C into 1 plus I raised to the power n minus 1 divided by I into 1 plus I. Now all the informations are given here. We want to substitute all this information in the given formula. So then it will become, see, the future value is equal to C, that is 1,000 into 1 plus 0.05 raised to the power 5 minus 1 divided by 0.05 into 1 plus 0.05. Then if you go for simplifying it, then we are simplifying this term, that is 1 plus 0.05, that is 1.05 raised to the power 5. Then into 1 plus 0.05, it will become 1.05. Then again we are going to find out the value of 1.05 raised to the power 5. It is equivalent to the 1.2762. Use the calculator. It will provide 1.2762 minus 1 divided by 0.05 into 1.05. Then we are going to subtract 1 from this particular value. Then it will become 0.2762 divided by 0.05 into 1.05. Dividing these two terms, then it will become 5.53. So our under term will become 1000 into 5.53 into 1.05. Then it will give you a value of 5,806.5. This is the future value of 1,000 rupees which you are going to invest on the 1st of January for the next 5 years at the rate of interest of 5%. Then its future value will be 5,806.5. Now we want to find out the present value of an annuity due. So the present value of an annuity due, which actually tells you, the current value of the series of expected annuity payment. It shows that, what future total to be paid is worth today. So similarly, the formula which we are used for calculating the present value of annuity due take into account of the fact that the payments are made at the beginning of that particular period rather than the end of each period, which we are already calculated in the case of an ordinary annuity. But here we are going to calculate the present value of an annuity due, where payments will made at the beginning of each period. So we can find out the present value of annuity due by using the formula that is which is equal to PV, that is present value is equal to C into 1 minus 1 plus I raised to the power minus n divided by I into 1 plus I. So here C is equal to, of course it is the cash flow, C is equal to cash flow in the each period, I is equal to rate of interest, and n is the number of period for which the payment is made. So based upon this particular formula, we can find out the present value of annuities due. So let us consider one example so that it will be more clear. See, you are going to invest on January 1st 1,000 rupees every year for next 5 years at the given rate of interest of 5%, and we want to find out what actually the present value of its 1,000 rupee which you are going to invest for the next 5 years, and this investment is made on the 1st of January, so that we can identify that this particular annuity is an annuity due because the payment is made at the beginning of the each period. So what are the information given here? C is equal to 1000, I is equal to the rate of interest which is 5 divided by 100 which is equal to 0.05, then n is equal to for 5 years. So the present value we can calculate by using the formula that is equal to C into 1 minus 1 plus I raised to the power minus n divided by I into 1 plus I. Just substitute all these values here, then it is equal to the 1000 into 1 minus 1 plus 0.05 raised to the power minus 5 divided by 0.05 into 1 plus 0.05. So we can simplify it. See, adding this particular term, that is 1 plus 0.05 which is equal to 1.05 raised to the power minus 5, and then we are adding these two terms, that is 1 plus 0.05 that is equal to 1.05. Now we are going to find out the value of 1.05 raised to the power minus 5 which is equal to 0.7835. Then again we are subtracting this particular term from 1, then it is equal to 0.2165 divided by 0.05 into 1.05. Then taking the quotient rule here, see here, if you go for dividing these two terms, then it is equal to 4.33. So it is 1000 into 4.33 into 1.05, which will give you the value of 4546.5. So here we are calculated the present value of the series of payment which you are going to make for the next 5 years with the amount of 1000 rupees at a given rate of interest of 5%, then your present value will be 4546.5. Now consider the last example. If you invest 2000 rupees on the January 1st in the every year for next 10 years at the rate of interest of 10%, and we want to find out here the present value of this particular annuity. So here the C is equal to 2000 rupees for next 10 years at the rate of interest of 10%. So 10% is the rate of interest, so it is equal to 0.1, and n is equal to 10 years. So here we can find out the present value of this particular annuity, that is annuity due, because it is payment is made on the January 1st of every year. So we can use this particular formula by substituting all these values in the given formula, then it will become 2000 into 1 minus 1 plus 0.10 raised to the power minus 10 divided by 0.1 into 1 plus 0.10. If you go for simplifying it, then 1 plus 0.1 which is equal to 1.1 raised to the power minus 10. Again we are adding these two terms, that is 1 plus 0.1 which is equal to 1.1. Then if you are going to multiply these terms, see here we are going to find the value of 1.1 raised to the power minus 10. It is equal to, see, it is 0.3855. Then we are subtracting this particular value from 1, then it is equal to the 0.6145 divided by 0.10 into 1.1. Then dividing these two terms, it will become 6.145. Then multiplying all these terms here, that is 2000 into 6.145 into 1.1, then it is equivalent to the 13,519. So the present value, this answer is nothing but this is the present value of the series of payment which is made on the January 1st, beginning of every year, for next 10 years at the given rate of interest of 10%, then its present value will be 13,519. So in this way we can find out the present value and the future value of annuity dues. So let me conclude here. Today we have discussed what actually mean by the annuities, where we defined annuities are the payments or the receipts of a amount at a regular interval. So then we discussed how to find out the present value and the future value of an ordinary annuity and annuities in due. I hope it was clear to you. In the next lecture, we will start our discussion on new area of mathematics, that is known as matrix algebra and its applications in economics. So we will see in the next lecture. Thank you.